Good morning. For those who know Justin or know me, you know I'm not Justin. Justin had a flight delay, so I'm Dave Rich, Sustainable Energy Manager at NPPD, subbing in for him. So again, we'll be using the mic to questions later on, so write down your questions so you don't forget. And John just talked about the evaluation form. So introducing, we have two great speakers, Carter Scott, Vice President of Transmission, has a law degree you can read all about in the bio section. Courtney Kennedy with OPPD has a bachelor in mechanical engineering and Spanish, MBA Creighton. So one interesting thing that's not in the bio is that Courtney's four predecessors all retired. I worked with all four of them. And so the good chance, though, that she will not retire before me. So with Justin's slides, there's a little bit of a commercial for National Grid. You can read through that. I'm not going to promote his organization, but he's a great. Sorry, I need to move the mic. Thank you. So these are Justin's slides. A great organization, and unfortunately he can't be here. He'll be here this afternoon, so you can catch up with him. Farmer friendly, again, that's a key in any wind or solar development. You need to find an area where all the neighbors are willing to go forward with the project. We've seen a lot of projects have a lot of challenges. This shows the outline of all their projects across the U.S., wind and solar storage. Storage 101. The key, I think, are some of the comments on the right, how fast battery storage is growing. That's 1736. There's 59 megawatts in 2010, now 1,736 by 2021. And that's estimated to grow to 17 gigawatts, another 10 times larger by 2050. And I personally think that number is low. And it's a lot driven by battery prices are decreasing. 89% decrease from 2010 to 2020. And this is focusing on battery storage, but there's many other types of energy storage that are being worked on right there. And again, it's going to be a major game changer, more of a focus on carbon-free resources. Unfortunately, with wind and sun, they're not dispatchable. You take them when you get them. It's zero. Typically, the variable cost is zero. So you use them when you can, but you need to be able to find ways to store them. Basically, he's got three things. One of the things with typically the lithium-ion batteries, they're very, very flexible. You can move from charge to discharge almost instantaneously. So you can take advantage of that. You can provide some stability. If you have them interfaced in with solar, for example, clouds come over, you can try to levelize that output. Again, discharge. There's different ways, and they'll be talking about different use cases of how batteries will be used. They can be used to store renewable energy. They can also look at transmission issues. They can look at price differentials in the market, take advantage of that. Lithium-ion batteries, again, they're the most common we talk about. They've been around for many years. Cell phones, laptops, power tools, EVs. EV out in the hallway has 80 megawatt hour battery storage in there. Then he's got compressed air. Again, very effective. NPPD was pursuing some options on compressed air in western Nebraska. One of the challenges when you bring out that compressed air, you burn natural gas with it to get the full energy value out. But again, one of the challenges with compressed air compared to batteries you can do incrementally. You can bring up small. When you get into compressed air or hydro, which Justin doesn't have on here, typically large steps, billions of dollars for investment, whereas battery storage, you can bring it in small increments. Other two, we had mechanical gravity. Again, a lot of work being done, bringing rail cars up the mountain and then letting them come down and discharge, so another option. And then flow batteries. Again, the benefits of flow batteries, many, many hours. So there's a slide. If you have any questions, ask Justin when he gets here this afternoon. Carter, you're up.
So my name is Carter Scotting, and I'm the transmission VP of Transmission at Ranger Power. Very happy to be back in Lincoln. It's been a little while, but very happy to be here with some colleagues and with you all in person. I think this is the first conference that I have been at in person for a couple of years, so it's really nice to be here. So Ranger Power is a utility-scale solar developer and storage. Of course, all renewable developers are now storage developers as well. We have projects that range from 75 to 600 megawatts, so we're doing larger scale utility connected or high voltage connected solar projects. We have about 7 gigawatts in the interconnection queue across 10 states. And our team sort of has been responsible for about 2 gigawatts of, that's probably a small number, but compared to what it is, but of energy projects across the U.S. And I think as a lot of developers are realizing, and Javier mentioned, it's really sort of a partnership approach with the communities that we're in. So we have really been very involved in our Salt Creek project is just east of Lincoln. We've been very involved in Nebraska for several years now, and really have built a lot of really great partnerships with these communities and with our landowner partners and our other stakeholders. So we really pride ourselves on that, and I think my permitting VP would probably tell me not to say this, but I think we've had a really smooth path towards a lot of our permits, not a lot of opposition, and I think it's because we're really on the ground, living in the communities that we're in. So a couple points. I was asked to speak about sort of storage from an IPP or independent power producer perspective, and I think I just wanted to highlight a couple, getting ahead of me here, a couple of sort of pretty major milestones. In 2018, FERC put out Order 841, which was a pretty landmark decision and a really, I think, forward-leading order on storage. It really sort of defined what an energy storage resource is. I think the biggest piece for an IPP is that it pushed all of the ISOs and RTOs to include storage as a part of their market design and allow storage to be integrated fully into the market. And this is not an easy feat. A lot of the compliance filings and work on that is still ongoing and will continue to go for several years. But it really sort of opened the markets for storage to be used as a market participant similar to other generation sources. There's a lot of work being done both on the transmission side with storage, but again, my sort of focus is it as a generation resource. Wow, this thing's got a mind of its own. So moving on to this slide, I realize this is a little bit dated, but you can sort of see the curve, and I think this continues to go forward. Is that the projections for energy storage is just it's a massive climb, and I think the inverse of this is true, that the costs for the storage technologies has really declined to the point where it is a very economical source. So what does storage do for us? Again, from an IPP's perspective, there are various revenue streams that storage is able to benefit from. It was mentioned SPP really is an energy market, so the energy arbitrage, buying power. So obviously there's the energy arbitrage, being able to buy power and charge the battery storage system and sell it back at a higher price. Capacity is a storage or a revenue stream for storage. It's a little bit different in SPP because there's not a sort of an active capacity market, but it does provide capacity support for the utilities to meet their requirements that they have a certain planning reserve margin. And also the ancillary services that can come from storage. Again, this is sort of not in all of the markets, but it can be a balancing resource, a spinning reserve. It can provide frequency response. It really can do almost everything, which is sort of the benefit of storage and maybe the challenges. And then, reactive supply, voltage control. It can be a black start resource, again, when the sort of rules allow for it. And that's when I think the 841 order really pushes the markets to accept storage and make sure that storage is accurately reflected and incentivized to be utilized on the transmission system. So I want to talk a little bit about sort of how storage is connected. And again, this is sort of from this facility standpoint. You can have, this is sort of, again, the transmission system. Storage can be connected directly to the transmission system as a standalone resource. It can be connected or co-located with a solar project, which is all of our developments are considering sort of a co-located storage facility. And then how that project is actually integrated into the solar facility, I think, is a really interesting discussion. Maybe not for everybody, but I'm a transmission geek, so I think it's really interesting. It can be connected, and most of our analysis is on the AC side, so almost as if you have sort of two separate generating units that are connected. They have their own inverters, and they can be really independently managed as a resource to the transmission system, both from the transmission side, so a local balancing authority can actually have some control over the storage when it's connected on the AC side and somewhat independent from, say, the solar or wind inverters on the in the project design. It's more efficient to have the storage connected on the DC side, utilizing the same inverter. Your charge and discharge and sort of flow-through rates are much higher because you have a greater efficiency. But again, you don't get the same level of control and sort of remote flexibility that you do when the storage is connected sort of not in front of the meter. That's sort of a tough term for it, but with its own inverters and connected on the AC side of the solar design. So these are sort of some general considerations that we have. Our Salt Creek project, which again is east of Lincoln, has a storage component. It's got a solar queue position and actually an independent storage queue position in the SPP interconnection queue. And so it really allows us to utilize the storage as its own resource. It can be AC connected. It could actually be independently connected with a separate point of interconnection onto the system. So it really allows us sort of a lot of flexibility to be able to offer both the sort of shaping for the solar project, enter the SPP market as those resources and revenue streams develop in SPP, and also could be sort of a standalone unit. And I think that's... I think I had some, pretty pictures. Of course, Tesla is the most, aesthetically pleasing storage facility. My mom jokes that she has a Tesla parked in her basement that helps them regulate power and switches on and off when they are disconnected from the grid, which happens pretty frequently in rural Vermont. This is a small transmission project in Booth Bay, Maine. And again, they're really sort of incredibly small components of a larger solar or wind facility. They can fit within a substation footprint. Many times they're a container ship that's brought in or housed in a warehouse type of a facility. So the permitting process and the sort of aesthetic review of storage is actually a very easy process, sometimes compared to some challenging permitting environments with some of the larger facilities that we build. And I wanted to mention too, storage, it is not a fuel source. Javier mentioned that it's not a capacity replacement. There is no fuel. It is taking power from the grid, and so therefore needs a power source and then discharging power to the grid. And so we really think of storage as a way to optimize our solar facilities, get the most amount of revenue and production in the times that is needed, and also that it's an energy regulator. It really allows and enables, I think, a future that is lower carbon and will be able to integrate all of these resources onto the grid in a very safe, resilient, and redundant manner. So I think that's all I had. Thank you.
All right, nice to be here. My name is Courtney Kennedy. I'm the manager of the Alternative Energy Program at OPPD, and happy to talk a little bit more about storage that we're looking at. So Carter discussed the use case where we're really looking at solar and storage, or storage with wind. And so what we also wanted to talk a little bit today is a standalone use case. And you'll hear the term use case really be a theme for how we look at storage. So in 2020, OPPD received a grant from the Nebraska Environmental Trust for standalone storage. So while there's a lot of great projects in the state looking at typically solar and storage paired, OPPD saw the need to really understand standalone storage as we look at how the system transforms over the coming years. And again, this is a different use case. So when we went for the grant, seems to be shaking. When we went for the grant, we specified the size would be about 1 megawatt. So we knew this was our first project, and we wanted the right size to test it out. We knew it would be in Cass County. That was something that we submitted in the grant. But what we didn't know at the time was the specific technology. Given how fast things are changing, we wanted to understand and have time to learn, is lithium ion the right way to go, or is there some other emerging technology that would fit our need? So that was open-ended. So again, as we say, use cases matter. So this graphic kind of shows different areas that you can plug in a battery on the grid. And there's more that aren't listed here. I think I've heard of battery storage referred to as a Swiss Army knife. It's got a bunch of tools. You can use it to do many different things. But if you think about a Swiss Army knife, you can't use all the tools at once. And so you've really got to understand what is your project, what are you solving for, and then design around that. So as we looked at this project, there were several considerations: cost, the grant requirements that we had to stay within, the timeline, the location we'd be putting it, and how we'd learn from it on our system. And so as we went through those considerations and analysis, we did look at the site, so specifically where we'd be putting it. We did a feeder analysis, and then we did techno-economic analysis. And I'll talk a little bit more about those. So where did we decide to put it? We put it at a substation, OPPD owned, as I mentioned, in Cass County. This is outside of Weeping Water. It's on OPPD's 69 kV system, but it's actually interconnecting to the distribution system, or 13.8 kilovolts. There was a lot of benefits to this specific site, one being just room in the substation. It's easy to add in, so we didn't have to get more land or go outside the fence. But there's a lot going on at this substation. It's on a rural part of our territory, so it's a rural circuit, but there is a significant load for that circuit. And so this allowed us to really understand some of the benefits for reliability, for voltage support, and even understanding what we can do in a transmission outage. And we can benefit from the distribution interconnection, but also having the transmission system there. Oops. So again, use cases, this is a theme. So when we looked at this project, where did we land on use cases? The first one is energy shifting. So this allows us to charge or discharge and to move electricity consumption from one time to the other. So you've heard of that, shifting the energy. That's a value of a battery. We're also looking at peak load reduction. This helps us look at how to reduce loading on the substation. Energy arbitrage, this is where you are charging off-peak or times of lower price, and then you're discharging on-peak. Voltage support, as I mentioned, the inverters on the batteries have the ability to inject reactive power, which helps voltage levels on that circuit. And then finally, and Carter mentioned this, and I'll get into it a little bit, but with FERC 841, even though this is a distribution asset, we're able to start to understand how this would play in the SPP market. And so this is a really big opportunity to understand not only the reliability aspect, but the market dynamics of a battery storage technology. And I shouldn't forget to mention there were some other benefits that we wanted to highlight: reliability, development of the operations internally, education and safety. You hear a lot about these assets. We want to make sure we're communicating and learning with our community. And then in the future, we look to really understand how this would participate in the SPP marketplace and take that learning for future projects. Technology selection, Dave or Justin, however you want to refer to him, talked a little bit about the differentials. And as I mentioned, we went into this sort of open-minded with the technology. But I'll tell you where we landed is lithium ion. And really because of some of the things Dave talked about. But there was just the market availability makes this easier to get, easier to understand. It has a high round-trip efficiency. It satisfies short duration. So here in a second, I'm going to talk about duration. And this is really a shorter duration use case. So that was a piece of it. And then there's different chemistries. And so I like this graphic, and we touched a little bit in Battery 101, but what does this look like? If you think about your cell phone, you have a cell in there, a battery cell. You take those cells and you put them together, and that's what gives you a module, The modules go into the battery racks. So if you think of servers, it's like a similar feel. And then eventually those go into the containers, the pretty containers that Carter showed you. So that's kind of what's going on with lithium ion. It's really jumpy. All right. Okay, a couple things to talk about when we look at designing and sizing the battery. You have the capacity. So this is the measure of energy stored in the battery, the megawatts that you hear about. For this project, as I mentioned, this was defined at 1 megawatt per the grant. A duration, this is the runtime of a battery on full charge in hours. So this is the hours component that you'll hear referred to. We looked at 2-hour and 4-hour, and I'll talk a little bit about the differences here shortly. But this is an important piece, again, for how you're using the battery, how much duration you want it to have. And then finally, the cycle. So this is a full charge or a full discharge, or the equivalent of the capacity. So this is something that we had to define up front. And this is something, as we were going through our learning, we understood this gives us, the more cycles gives us the more flexibility. And again, as we're understanding how this would play in a reliability setting, but also in a market setting, this was something to consider. So where did we land? So as you can see, we looked at 1 megawatt, 2-hour and 4-hour, and then 250 and 365 cycles a year. And you can see the relative cost comparison here. Really, the biggest cost difference is in that duration. So what we are trading off between A, B, or B and C is 2-hour versus 4-hour. That's about 40% higher cost. Excuse me, the 2-hour is about 40% lower cost than 4-hour. So there's a significant trade-off in there. To go from the 250 cycles to 365 cycles, it's a very small change, which is about 3% higher in cost. And then you can see in terms of OpEx cost, they're fairly similar across all of them. So as we went through and said, what are our use cases? What do we want to get out of this project? What's the best selection? It was A, 1 megawatt, 2-hour, and 365 cycles per year. And so we had to know that going into our RFP and our design. So a few other things that are value of this project. Again, a lot of them, administrative, educational, and operational, kind of how we bucketed them. But we're really looking forward to understanding impacts in the market, the operation on the grid, how to go through contracting an asset. I may not have mentioned, but this will be an OPPD-owned asset, and so that's something new that we're learning through the contracting of it. As Carter mentioned, FERC 841, so we're excited to understand what that looks like through SPP. There's a lot of internal and external educational benefits. And so we look forward to having the conversation with our communities, sharing our learnings with the Nebraska Environmental Trust and other utilities across the state. And then finally, seeing this play out, how does this look from an operations and maintenance perspective? So finally, just a little snapshot of the project. As you can see, we've been on a journey. We got the money or the grant funds in 2020. Since that time, we've spent a lot of time understanding the technology. So we didn't want to just jump in and get something on the system. So we went through a request for information with suppliers on the battery storage side. We did workshops with them, and that really helped us understand what we're after and what we're solving. And then we brought on an owner's engineer, put out an RFP, went through the power review board, and now we're at the phase where we are analyzing the RFP and look forward to procuring the asset and having it operational in 2022. So with that, this is really jumpy. I'll just give it to Dave. We'll take any questions. Thank you.
Courtney, you talked about the planned installation in 2022. If this would have been a transmission integrated battery, what's your best guess for when it would have been installed?
If this was a transmission asset, then we would be subject to the interconnection process. And I will not steal thunder from the SPP discussion later, but as many of you know, there is a significant time period to have an asset studied. So if this was a new project, it could have been a 3-year sort of interconnection process versus distribution is something that OPPD or other utilities kind of study and integrate themselves.
Yeah, similar to the first-time permitting challenges with any wind and solar project that I'm sure you've gone through, what challenges do you see or anticipate for this first-time process with battery storage?
Sure, and I am the interconnection expert, not the permitting expert, so I will answer that question to the best of my abilities. The permitting process for storage is much more similar to a construction project. So, what we may see in the next, say, 5 years is for municipalities or local permitting jurisdictions to start to develop some ordinances that are more responsive to storage, similar to what we've seen with solar and wind as they've sort of evolved on the system. But it is really a building and electrical infrastructure to house that. I think there are concerns, obviously, about sort of the materials, the technology, the safety of the storage. There have been, some examples of some challenges with storage that have been installed. I don't think that the cases that I've seen have been not necessarily with the storage itself, but the electrical connections and the inverter technology. So I think that, currently the permitting path is that you can permit, it's a building permit. And you have to make sure that you abide by all of the local criteria, and then you have to permit the infrastructure. So the actual facility, especially if it's co-located with a larger solar or wind project, is really a relatively small impact. Again, it's like building another substation or sort of a warehouse alongside a substation. So, and I don't know if you found that, have you guys permitted yet, or you're...
No, we're in a little bit different situation, but I would say it's a much easier when you're in a substation that's already existing.
Yeah.
Good job.
I was just wondering if you are planning on using those battery storage as a peak shaving device, and if you can speak of what the SPP is allowing or not allowing on something like that?
Yeah, so today, I guess to start the project, we will not be registering it in the market. So the plan is to get it on our system, to work through some of the use cases I mentioned, and really understand it from the distribution operation. I think the goal long-term is to register it in the market, and SPP is looking at different products, so we would expect to participate in those. So at this point in time, it's really focused on kind of the distribution, local operation of it.
Yeah, and I think the peak shaving is a really interesting aspect of storage. I mean, the Swiss Army knife is a great reference. I think the challenge between sort of transmission owners and IPPs is that there are a lot of storage benefits, such as peak shaving, which save in a capacity requirement, and yet there's not a revenue stream to sort of support the fact that the IPP is providing that resource. And that's, I think, a debate going on with a lot of ISOs right now, where there are transmission aspects of the storage facility that are very beneficial, and there are sort of generation aspects of the facility that are very beneficial. So, an IPP doesn't necessarily get the benefit of a peak shaving savings, and yet the mechanism is not quite there yet to figure out how to sort of share in those costs.
How about one of you can discuss the difference between the current federal tax credits for battery storage and potential future tax credits?
Also not a tax lawyer. Really checking off a lot of boxes here. So currently the ITC rules are that storage, when it's co-located with a tax credit eligible facility, wind or solar, that as long as the storage, you can sort of show that the storage has been charged from the solar project and not from the grid, that can be a part of the ITC eligible project. The DC connection is obviously a much easier story to tell. The AC connection, you really have to make sure that your metering is pretty buttoned up to make sure that you can prove that. And then Dave actually asked another question about sort of, co-located versus an independent storage project. I think that the independent storage might qualify for future. I think there's work towards allowing independent storage facilities to have some ITC qualification. It's really about what your ITC lawyer will write you an opinion on. But But co-located, let's say they had sort of two separate connections into a single substation, you could probably prove that that was at least being charged by the solar, even though it was sort of entering the grid and coming back. It's really a metering question. If you have your storage project 30 miles away, that's just a more challenging opinion to write for the tax lawyers. So I think that has not been done, but financing a co-located storage project with ITC qualification is currently I don't know. I wouldn't say the norm, but that's currently the sort of ITC allowance.
Anything to add, Courtney?
No, I think she has it. Today it must be co-located with solar or wind to get the tax credits.
And if I understand it correctly, it's solar, you collect the ITC. With wind, it's a PTC typically. You can take ITC on wind, but most wind projects are production tax credits.
Right, that's correct. All of our solar projects are using the investment tax credit. Yep.
And so if the wind's taking production tax credit, there's no tax advantage for the battery storage.
Actually, that's an interesting question. I don't know if there is a way to claim production tax credits on storage that has been charged from a wind facility. So I've been out of the wind business for a couple of years now.
How about what's the challenges of getting battery storage equipment? There's, from what I hear, the cars are being delayed because of batteries. I've got a Bolt, it's getting recalled because of the battery. Battery manufacturers are having trouble keeping up. Can you speak to that?
Yeah, I mean, you may be closer to the supply chain.
I was going to say, I think from sourcing perspective, we're doing that currently. We are seeing some delays. I will say that we're still marching towards a 2022 COD, and that seems to be okay. I think the size and the scale may depend, may impact that more. So a 1 megawatt battery is big for us, but it's maybe not as big for others in the industry. And so that's helping us, I think, move through sourcing. I don't know if you have anything else to add on your perspective.
Yeah, I would say it's kind of an interesting time in the storage, and especially some of the larger storage installations. It's a very new technology in the interconnection queues, in the markets. And so, wind and solar have been around for a long time. I think that the supply chain issues are really hitting projects that, we're intending to be built today, and in 6 months from now. I think it's kind of an interesting time in storage where it's sort of far enough out. A lot of these projects are still working their way through the interconnection queue. They might have a 23, 24, 25 in-service date or construction timeline. So it'll be interesting to see how everything moves in the next year or two, but I think there are just not the storage facilities like there are wind and solar that, people are ready to start to put steel in the ground, and that steel is not there. So maybe it's just a hopeful thought that by the time, a lot more of the storage is becoming, these installations are sort of tenfold towards 2050, that we will start to see some of that leveling out.
Let's give both Courtney and Carter a round of applause.